In this video, we are going to explore how temperature and pH influence the function of enzymes and, as a result, the rate of enzyme-controlled reactions in biological systems. To begin, let us first consider the effect of temperature. A typical graph showing enzyme activity versus temperature demonstrates that in the initial phase, as the temperature increases, the rate of the reaction also increases. This rise occurs because the particles involved in the reaction gain kinetic energy. With more kinetic energy, these particles move faster, collide more frequently, and have more energy during collisions, making it more likely for the enzyme to successfully bind with its substrate and speed up the reaction. However, once the temperature reaches a certain point, which for human enzymes is approximately 37 degrees Celsius, the reaction rate hits its peak, known as the optimum temperature. Beyond this temperature, the rate of the reaction begins to drop sharply. This decline is caused by the high temperatures breaking the weak chemical bonds that maintain the enzyme's specific three-dimensional shape. As a result, the active site of the enzyme begins to change shape. If the shape of the active site alters too much, it will no longer be able to accommodate the substrate, and the enzyme becomes denatured. When denaturation occurs, the damage to the enzyme is irreversible, meaning that even if the temperature is later reduced, the enzyme will not regain its original shape or function. For the enzyme in our example, this denaturation begins at around 45 degrees Celsius. All enzymes have an optimum temperature, but that value differs depending on the type of enzyme and the organism it is found in. Now, let us consider the second important factor, which is pH. The pH scale measures how acidic or alkaline a substance is. Enzyme activity can be greatly affected by pH levels. According to another graph that illustrates this relationship, we see that if the pH becomes too high or too low compared to the enzyme's preferred level, the reaction rate decreases. This reduction happens because the extreme pH levels begin to interfere with the bonds that help maintain the enzyme structure. When these bonds are disrupted, the enzyme's active site may change shape. Initially, this change might be small, allowing the substrate to still bind, although less effectively, which slows down the reaction. But if the pH becomes even more extreme, the shape of the active site may change so drastically that the substrate can no longer fit at all. At this point, the enzyme is considered denatured and becomes permanently inactive. Each enzyme has its own optimal pH, which depends on the environment it is naturally active in. For instance, most enzymes in the human body function best at a neutral pH of around 7. However, enzymes that work in the stomach, such as those responsible for breaking down proteins, function best in highly acidic conditions with an optimal pH of about 2, because the stomach itself is filled with acidic gastric juices. Understanding how both temperature and pH affect enzymes is essential in biology, medicine, food production, and many industrial processes that depend on enzyme activity.